Hey folks, Eric Hanson here. For those of you who don't know me from before this, I'm Eric Hanson, and this is the Aquameta podcast. What the heck is Aquameta? So I've been working on a software project for about, I don't know, 8 years, like directly on this project, kind of off and on, not full time, but like as time and will and joy permits. Yeah, I've been working on a new way to program computers. I think it's going to take a while to explain what the heck is rattling around in my brain. Um, but since this is the first podcast, I thought I would um, kind of restate the intended goals of the project and also talk more about kind of the place that I see it in the world and also make a bit of a personal statement about um, who the heck I am in my own limited subjective assessment. So um, let's start with that. So Aquameta is pretty much an entirely different paradigm of making software that I think challenges some of the base core assumptions of what programming is and um, the place computers hold in our world. Um, okay. How so? Well, so whenever you create a piece of software or a programming tool, you start with what you might call first principles. Um, and those are kind of the things that are on your mind when you're thinking about what people will have to think about when they use it. And uh, what makes Aquameta a completely different paradigm is that that list is almost entirely distinct from what you might call modern um, software development practices. In that, uh, it's based on relational data. So here's the anomaly, or at least one of the many anomalies in this arc that the tools of the trade have taken over the last 60 years or whatever it is. Um, that there seems to be this division between programming tools and data. And it's kind of this attitude that the programming tools work on the data. And there have been a whole bunch of different databases over the years, but uh, as certainly some best practices or tools that are good enough have shown up, especially the relational model and all the relational databases that run like 80% of the world, um, what they've proven is that relational data and the relational model, Codd 1970, he kind of figured it all out way back then, but it's an overarching abstraction, one that you can take the relational database into pretty much any environment and model it, make what they call a relational model or a schema, right? And we've done this in countless different domains over the last really like 50 or 60 years since the relational database and the theories behind it became more solidified and commonplace, um, and it works. You can go into a bank and like use this structure of relational tables and foreign keys and distinctions on those tables, columns, and make a pretty good model of, I mean, like a very synced up model with whatever you're trying to model in the real world, and this database schema that mirrors back to you whatever the heck you intend to think about it. And it's flexible enough to roll into just about any environment and model it and break it all out. And then once you model it, you can start putting facts in there. There you have this customer and you have this product and you have this vendor, and on and on and on in the e-commerce world. But if you go into quantum physics, you've got these atoms, and these atoms are like in a table that looks a lot like the periodic table, except for there's only one one what's that, a column? Yeah, they're all in one column, sort of. Um, but and start making distinctions on the periodic table and the atomic system and the particle system and the quark system, and build out a relational model that mirrors that just as well. It's just as apt of a tool for doing quantum physics as it is for doing e-commerce, in that it looks at the entire world and say, what I care about in this world is classifications and distinctions and relationships between classifications. And as it turns out, using these fundamental primitives of the relational database, it gives you a kind of infinite flexibility. And that's really cool. Okay, so that means that you don't have to use a different database for running an airport than you do for running your baseball league or whatever. It's a crazy power. It's hard to overstate how powerful that is. A standard upper ontology, they call it in philosophical informatics terminology. But so it's been a huge success. And what we've never really done as an industry is say, okay, if all this stuff outside of the database, like in the real world, as they call it, if all that stuff can be modeled with this same tool, then what if we turned that around and turned it on our programming stack and said, how do we model everything in because the programming stack is not a special domain of complexity. There is no special domain of complexity, at least in the level that I'm talking about it. There's just a lot of classifications and distinctions. And, if you were to turn the database back on the software stack itself, man, there's so much chaos down there that would benefit tremendously, in the same way that when you go into some office and they've got all these spreadsheets over here, and this guy's got his notebooks, and this guy just does it in his head, and pull all that information in and kind of make sense of it, and potentially even refactor it a little bit, and bring it into the relational database. That transforms industries. There's a reason why businesses keep putting all their stuff in the computer, in the database, and that's because it works, and it's highly effective and transformative for building multi-user systems that have to coordinate with each other around a bunch of expectations, right? And programming isn't like that. It's a colossal shit show. Reusable components. Oh my gosh, it's such a mess. And it's because we haven't developed shared standard upper ontology other than ones and zeros. And like files would be the Unix paradigm. What is everything to Unix? It's a file, right? What is everything to a hard drive? It's a 1 or a 0. And these are like, the highest abstractions that we've chosen to kind of adopt as an industry. And other than that, we make a million different package management systems and a million different programming tools and programming languages, and they use different compilers, and on and on and on. And it's total chaos. It's total chaos in comparison to this thing that doesn't exist, right? But that's what I'm saying, man, is that there's another way to do all this crap. And the way to do it is to put everything in the database. And what you get from it is I'm not ready to make a value pitch. I'm like a list of benefits. I mean, if you know anything about databases, just ask yourself, like, why, when you create a user in Unix, in Linux, is it this Perl file that's 800 lines long called add user that basically all it does is insert and update rows in the database. But it's in a file, and since we don't have a database, you have to rewrite this whole thing from the ground up. That adds a user that does something that a database does, like out of the box, better than add user does it. As one example. But yeah, ACID, the transactional properties, the 4-letter acronym that is like, here's why relational databases are awesome. Google that. Having a query language that is uniform and can operate on a shared or a standard information model in a standard way. I mean, SQL's not the most elegant, beautiful language in the world, but what I could say about it is that it's a tool for the right problem. Like, I could certainly imagine a better query language, but just having a query language is a huge leap forward over having a bunch of stuff spread out over JSON and YAML files and source code and configuration files, and having to write programs that introspect that. One word to throw out there is homoiconicity, which is that, like, you program the thing, it's able to represent itself. That's also a reified is another relevant word here, but it's able to represent itself using its own definitions, and it's able to manipulate itself using its own processes. That's a system that can evolve. Like the cell is kind of like that, in that you can plug in obviously a different chunk of RNA and totally change the freaking operating system of a cell. And computers, we haven't achieved the level of elegance that the biological world even has, because we don't have gene expression in our stack. I don't know. I'm probably being overgeneral, but like, I'm not trying to make an academic argument here. I'm trying to make an assertion that hopefully I can build on over time. And so there's the assertion. There's a better way to build software that is a complete paradigm shift. It's putting everything in the relational database. If we could like snap our fingers and try to adopt some objectivity here, or if the aliens came down and looked at us, they would say, you're using the database to make sense of all of the rest of the world. It works, clearly. You've been doing it for decades. Why aren't you doing it yourself? And how do you think that your code base and your problem set is special? It's not. It's just more complexity. It can be trivially relationally modeled, and the entire industry would like be a lot better, a lot better. So that's what the Aquameta podcast is about. And I've got a prototype that's really almost more than a prototype. It's becoming fairly mature in its. I mean, it's still terrible in comparison to what I would like to build, but there's no way in how I'm going to ever build it myself. And it's just too big of a job, and it might be far enough along that one can use it, and actually, like, it can establish this replication and evolution and scaling. Like, if it can replicate, if it can evolve without breaking, and if it can be worked on by multiple people at the same time without creating a giant storm of chaos and mess, then it's ready to show to people, then it's ready to ask people to use it. And I don't know that it's there yet. Like, I certainly wouldn't guarantee the user experience, but I think part of the purpose of this podcast is to talk about the ideas. Another part is to like work on it and live stream it and get people to see kind of that I can use it. The thing is that I'm the one that made it. There's a few other people that can use it in the world, I would say, well, but that's because I know a lot of the little tricks. And like the way I use it right now is to work out, like, as I'm trying to use it for a problem, I've got this whole technique for how I want to live stream around time tracking and or turning a live stream or a podcast, whatever, into a usable kind of tutorial video, even though I'm jumping around and I'll be using the tool and then I'll see some feature that I don't like and then I'll shift to working on the tool without missing a beat, by the way, and then go back to working on the tool. And like, if you're working towards a end goal, it's never like I'm only going to work on this one linear thing. It's all these different fractaling out tasks that have subdependencies and block each other. And so the idea of a linear podcast being in any way having one subject, uh, it would take a lot of like planning, and I don't mean that in the good way. I mean it in the like, to make a thesis, like you'd have to make the thesis before you started working on it, and if you don't do that, then you've got this scattered development process that jumps across all these different sectors of the problem space, and yet that's the natural progression of working on a problem or towards some goal, is this necessary fragmentation and jumping back and forth, unless you're writing a damn novel. And even then, you develop the character and then you go back and add something in the first chapter because it's going to totally fit in the eighth chapter or whatever. It's not even linear then. So the goal is to create a podcasting system that kind of rolls with the natural development cycle without losing what in the end could be kind of an overarching narrative if we weren't bound by the progression of freaking time, man. Uh, so, yeah, that's kind of the vector, Victor. Um, so then who's me? Well, this project has a very personal meaning to me because I've been working on it. I mean, like this code base particularly, I've been working on with other people for like 8 years, and uh, um, had a company and had a bunch of money and spent it all on this. And next time I get some more money, I'll probably spend it all on this. And um, but the project, the vector kind of even predates that whole experience in that. Um, I was really into this stuff when I was like 19, 20, especially 20, right around there. And then when I was 24, I had a mental breakdown, and it's kind of warped my life and to some extent the lives of people around me, because I've been working on it so hard and thinking on it so hard. And I don't know, the mental breakdown was a weird thing. I'm not like I don't I'm certainly not standing here as a moral authority on anything, or exemplar of how to live one's life um, without being too hard on myself. But it's definitely true that like my life in pretty much every aspect, like, am I a great brother? Probably not. Am I a great employee? Probably not. Am I a great physical specimen? No. um, am I, you know, I don't know. I guess there's some things that I'm good at, but like, I sure, uh, I don't know. This mindset, like, I lost some stuff when I had a mental breakdown, and it never really came back. And I have a kind of like moral flexibility and comfortable in uh, compromised positions, because I don't know. I feel like I used to have like such an incredibly strong uh, obligation to society, and now I feel like, I don't know, maybe I'm using this project as an excuse to be a bag of shit. But I think it's more complicated than that. I don't know. But just in case you were wondering what old Eric thinks of himself, there's a there's a slice. So, but I do think that this project is worth fighting for and pursuing, and even if I'm not the best person to be its vehicle or whatever. Um, so, and like, why is now the right time to talk about it? Well, that's a great question. Um, in part, because like the closest answer is like I did talk about it, uh, but there was nothing really actionable about it. Like you can talk about big ideas about changing the whole software industry, but where the hell does that go until you build something and uh, prove it? And something that other people can act on other than saying, "Oh, that sounds interesting. I'll have to think about that." Um, but I have built it. But it's more than just that too. Uh, I don't know. I think now's a really like why the heck do we want to make a better programming experience? Like asks questions that are way more human than technical. But um, man, the industry's gotten really like the profit driven aspect of how technology has evolved has really failed to serve the people that it allegedly was supposed to be for. I'm not going to discount all of the internet because like we're in the middle of the coronavirus here, and where the hell would we be if we didn't have technology? It would be much, much worse in some sense. I don't know. But then we also, on the plus side, we wouldn't be sitting at home staring at our damn Twitter feed. So pros and cons, but yeah, man, like what I always hoped in the people, the great visionaries before me, what they thought the internet was going to turn into was like this tool for organizing with each other in a decentralized way, and collaboration and the joyous kumbayas of a species thriving in peace together. And that didn't pan out. Not yet. I mean, I'm not all this doom and gloom either, but the way we use technology right now is such a time suck, and they don't ask us for our time. They just kind of take it because our stuff is like their stuff is so interesting, and we're these dumb monkeys. And so it's it's in our nature to be tribal and to be obsessed by like shiny objects, but it's also in our nature to collaborate with each other. And I feel like that second aspect has really not been monetized because it's not so easy to monetize. But I think we gotta use this stuff for humanity's benefit more than corporations' benefit, especially right now. And so, what the hell? That's kind of the philosophical bent. Like, how do we work together better? What are the opportunities that we can pursue together that make us stronger than when we're alone? And what are the things that we could, work on together that like, man, that would benefit everybody. I don't know. There's that, like, again, I don't have this all penciled out. I just kind of want to touch on what I'm thinking about, but there's a lot that technology could have done for us and still can. That's much more in line with serving humanity than what we've done with it. There's a lot of opportunity there, and so like that's why I think people being able to program would be so cool, because so many people have good ideas that don't necessarily have a business model immediately behind them, and they don't have the skill to do it. And if it was just this thing where you could plop, here's a piece of code that we can all organize around and use, and it unites us towards some common goal that is way more more interesting than what was before it. That's a really good thing for humanity, I hope. I mean, if it's not, then we're really screwed. And I just have to hope that it is. But if that was easier, there would be more of that. And so uh, that's why I think it's worth doing. So anyway, that's the Eric Hanson podcast. I don't know I don't even, it doesn't even have a name yet. I guess probably call it Aquameta. But in the upcoming episodes, I'm going to be pulling some other people in that have intimate knowledge of the system or don't, and great thinkers, old friends that I have known, and maybe even some new people. So, yeah, I guess that's it. Thanks for tuning in, and stay safe during the pandemic. All right. I'll see you later.